Okay, so let's take a look at a review. The first, what is it, 10 questions? So find the missing side of each triangle. Leave your answer to simplest radical form. Since we have right triangles, I'm going to use Pythagorean theorem. Right? A squared plus B squared equals C squared, where C is the biggest side. So the other two are A and B. It doesn't matter which one's A or which one's B. So I'm going to write this as x squared plus 13 squared is equal to 15 squared. Remember, C, the hypotenuse, is the one that is by itself. So x squared plus 169 is equal to 225. If the two numbers were separated with a plus, I could just add them. But since they're separated with an equal sign, let me move the 169 to the right side as a minus 169. So x squared, 225 minus 169, that's what, 56? So x is the square root of 56. Make sure you do simplify your radical if you can. Remember that one, I'm going to break it out as two numbers that multiply equals 56. I'm going to think of 8 times 7. My 8, I'm going to break it as 4 times 2. My 4 as a 2 times 2. So I have a group of 2's, so that goes outside. I have two singles. So inside I'm going to write 14 because I multiply my singles. If you have more than one group, don't forget to multiply your groups as well. So make sure you do simplify your radical. Right. Any questions for the first 10? Number 3. All right. Looking at question number 3, the biggest side in this case is the hypotenuse, x. So I'm going to call this 5 squared plus 8 squared is equal to x squared. So 25 plus 64 is equal to x squared. Now they're only separated with a plus sign, so I can just combine them, add them. 25 plus 64 is 89. So we get that x equals the square root of 89. If you can simplify it, simplify it. In this case, we cannot. So that's it. X is the square root of 89. Number 5? Sure. The hypotenuse, in this case, is 4. So I'm going to write this as x squared plus radical 7 squared is equal to 4 squared. So x squared plus 7 equals 16. A radical, when we square a radical, the radical goes away. So it just becomes 7. Let me move the 7 to the right as a minus 7. X squared equals 9. X equals the square root of 9. So x equals 3. Now that I see some radicals, I know I don't have them on the review, but we did practice it over when we learned it. In case you have a number, well, there's a number outside in the radical, as an example, let's say I had 2 radical 7, and I had to square it. Like, I'm doing this as an example. Because I have a number outside and a number inside. When I square it, I square the number outside, which in this case would be 4. I square the number in the inside, which in this case is 7. So I will get that as a 28. And I'm saying that because on the test tomorrow, you might have to do those. But I know we reviewed those, we worked them through the weeks that we've done this, so you should know how to do that. Any questions on the first 10? 7. Okay. Number 7, the hypotenuse is radical 14. So let me write this as x squared plus 3 squared equals radical 14 squared. So we get that x squared plus 9 is 14. Remember, the radical squared cancels the radical. So let me move the 9 to the other side. X squared is 5. So x is the square root of 5. We cannot simplify anymore, so we leave it at that. Simplify if you can. All right. Any other questions for the first 10? Now, starting at number 11, instructions say to find the missing side lengths. Leave your answers as radicals in simplest form. So we have the two kinds, 45, 45, 90, 30, 60, 90. I'm given the hypotenuse. For me to solve for x, let me write down 10 radical 2 to begin with. Let me write down the number. If I was getting the hypotenuse, I will multiply by radical 2. But since I'm going backwards, let me divide by radical 2. The radicals cancel out, so x is equal to 10. The cool thing is that y is also equal to 10. Right? The two sides are equal. That's a little recap on the 45, 45, 90s. If you have the side and you're going towards the hypotenuse, you multiply by radical 2. If you're going backwards, then you divide. And you know the two sides are equal. But then if you have the 30, 60, 90, like question number 12, let me do a little recap first. Let me do the little rule. I want to start from the small side. This side, the small side. If I go to the hypotenuse, I multiply by 2. Not radical, but 2. For the hypotenuse. Starting from the small side, to get to the larger side, you multiply by radical 3. And if you're going backwards, you divide. So question number 12, I'm starting from the small side. To go to the hypotenuse, let me write down what I have first. I know I have to multiply this by 2. So I'm going to put my 2 on top. The 2's cancel out. So I just get 3 radical 2. For us to get b, let me start from the small side. I have to multiply by radical 3. So on top, I have 3 radical 6 over 2. Simplify anything if you can. In this case, we cannot. I know on this kind, the special right triangles, we practice basically everything. Simplifying radicals, rationalizing denominator, everything we've practiced before. So the test tomorrow will be heavy on these type of problems. I gave you guys 2 sections, but the second section reviews a lot. So it will be heavy on these type of questions. All right, any questions on the review? Yeah.
How many questions are the test?
It has 2 questions from the first section, so 2 of those, and 8 of these. Yeah. 28. All right, so I have the small side. I have a 30, 60, 90. Have the small side. To get to the hypotenuse, let me write down what I have first. I have to multiply this by 2. A whole number and a radical, I cannot combine them, so I just leave it at that. 2 radical 3. For y, let me start with the small side. I know this case I have to multiply by radical 3. Radical 3 times radical 3 is radical 9, better known as 3. Okay. Any other questions? No questions? We're good? All right, let me take roll really quick.